Right, we are busy with calculus. We're on the edge of finishing up. The last bit of work is going to be maximums and minimums and speed and all the practical applications of calculus. But for now, we're still busy with the graphs. But funny things that can be asked. The previous one that we did was if I give you the derivative and you've got to go get the original graph, but just a sketch graph. Are you with me? This last bit is all interpreting the wording. Well, it's not wording, it's math wording. If I've got f and they're telling me here it is a cubic graph, they're not saying find A, B, C, and D at all. They're just saying, please sketch me with this information that's been given, f. So now you've got to realize what are they giving me here. So if they tell me that f of -1 is the same as f of 1 and the answer is 0, what's going on there?
X intercept.
What are they giving me?
Points.
If it's points. If x is -4, because that's what we read. This is why if x is -4. And if x is -4, then y is equal to 0. Which is the same as if x is 1, y is also 0. It's just, they're trying to trick us here. But it's basically, write them separate and see that if fx of that is 0, and fx, was it 1? Yes. Is also 0. You could have written it separately. Then it makes a little bit more sense, maybe, to know that if x is -4, then y will be 0. That's what that mathematical language means. And so for this one, if x is 1, the y value is 0. What is that? That's your x-intercept. So can I start sketching?
Yes.
Yeah. I think I'm going to maybe have to erase after a bit, but I know that the x-intercepts are at -4 and at 1. And remember, it's a sketch graph. So please don't make it so small you can't see what's going on then. It's not scaled. Next thing, interpret what's going on here. The
Parabola.
gradient
Oh.
is
0.
turning points. Interpretation, it's not level 1. This is interpretation. So the derivative, which is the gradient, is 0, making these turning points. Again, I would have liked it if they had said this one separately equal to 0, this one separately equal to 0. But you know that if x is equal to -4, and what's y?
0.
Well, it's that same point. Do you see it? So I do know it, and that would be my turning point. But it's all interpretation. If the gradient is 0, I have a turning point. You don't write that, I will see it. And then if x is
2/3.
2/3, I will also have a turning point. But do I know the y value?
Yes.
Where?
Isn't it 0?
This is the gradient that is 0, where x is -2/3. It doesn't mean that that value there is 0. I don't know what it is. How do I know that this was 0? Because I just did it. If the point -4, 0 is the x-intercept, and at -4 you also have a turning point, it has to be the same jolly point. So it's not only an x-intercept, it's also a turning point. And usually what MAM does is I make my turning points with x's, whatever you like. But that 2 and 3 is where? So 2/3, I'm going to make myself a little bit more space here, make that 1. So let's say 2/3 sit over here. That's my x-intercept, right? So where will my other turning point be? Somewhere here. But that's not enough information unless I read the last sentence. I don't know where I must turn. It has to turn somewhere by x is equal to 2/3, but this says something. That between -4, which is the one turning point, and 2/3, which is the other turning point, this graph is?
Decreasing.
Show me with your hand. So if it's got a decrease between this one, then that one has to sit somewhere over there, not at the top. Because it's got to be decreasing. Decreasing means it's got to go this way. So if it turns there and it is an x-intercept as well as a turning point. It's going to go up, turn around and go down, and back up again. And that's all the information that you have. How many marks?
3.
About 3. But it's a lot of interpretation, and you have to read carefully the math language here, saying that if x is -4, the y value is 0. If x is 1, the y value is 0. Meaning that this is my, without words, they told me that that was my x-intercept. Then they got to the gradient. The derivative is the gradient. If the derivative or gradient is 0, I have a turning point. Where are the turning points? At -4. This was only because -4 was also an x-intercept, and I knew that the y value was 0. That's why I knew exactly where that turning point must be. The other one, I don't know, and I still don't know. All I know, it's got to be somewhere below the x-axis so that this thing can be decreasing. So again, let's talk a little bit, because that's the end of the sum. Let's talk a little bit about concavity while we're on this. Where is the concavity changing? Between the two turning points. So if you want to work it out, you'll have to take a calculator and say between -4 and 2/3, what is exactly there in the middle? Because that would be your point of inflection. Do you have a formula to do the actual derivative? Because for that, you'll have to do double derivative, right? But if I just asked you now, where is the point of inflection, you should know it sits exactly between the two turning points. And that point of inflection, what is it for your graph? It's where the concavity changes. From concave down to concave up. If you had a sum, which you don't, and you had the expression, how would you work out, for instance, what the concavity in -5 is? You'd have to go to the double derivative, work out, say for instance, the double derivative was of that -5. Let me make that -5. -5 was equal to, I don't know what the answer is, but it will have to be a something less than 0. I don't know what it is, but -17. I don't know, because we don't have the graph or the equation. Are you with me?
Yes, ma'am.
Anywhere over here after the point of inflection, changing the concavity, anywhere there, at 1, at 65, wherever, if you go to the double derivative and fill in that 65, you will get a positive because it's keeping the water in. So concavity is up. That's just for extra. Okay, so we are again on the translation from English into, I almost said geometry, from English into mathematics, mathematics into English. This mathematics says, I'm busy with what graph is this? But it looks funny.
Yeah.
What is this form that it's been given in? X-intercept. What's the square story?
It's bounces.
Two of these x-intercepts are the same, meaning
Bounces.
it's a turning point. There's so much standing there in English that's not standing there. You've got to read it. It's x-intercept. What is A, by the way, in the sum?
1.
You're so clever. It's 1. It's there. You just don't see it, it's there. So if I had to tell you to go and get me the equation, you know that A is 1. Are you with me?
Yes, ma'am.
The x-intercepts, two of them are the same, so one of them is also the turning point. Knowing that. So I know that it's going to bounce against the x-intercept or x-axis. What does this tell me?
It's the coordinates of
That's a point. If x is -1, y is 0, I've got a point. What point? An x-intercept, because the y value is 0. Let's start seeing what we can do with this. So if at 1 I've got an x-intercept. Okay. The next one,
Maybe it's
let's go
-1.
-1. Big mistake. Next one tells me something more about that. So maybe don't just start doing stuff. The next one tells me that I've got a
Radians.
gradient
Turning point.
I've got a turning point. The gradient is 0, so this is a turning point. Oh, so that
Is it
is a turning point. That's where my graph is going to go, turn, whether it's from the top or whether it's from the bottom. That's a turning. You see this?
yes, ma'am?
Because the gradient is 0, I have a turning point at -1, and usually I don't know what the y is, but now I do because it was given in the previous one. The other one is also a turning point at 2 and what?
We don't know.
Unless maybe somewhere it appears, then you do know where it is. It does appear.
There.
Right at the bottom, if you carry on reading, it says, if x is
2. Y is negative 6.
so it's not unknown if you keep reading. So you've got a turning point very specifically at 2 and -6. So say this is 2, -6 will be around about there. Very particular where it is. Okay? Then I think they didn't need to say much more. Because this is just a heap of information saying what we've already expected to happen there. How can it turn there and there? Show me. Yep, everybody's got it. Has to go up, turn, to go down again. It can't turn there. What's happening to get back down here? You can't. Has to be up, down, up. And I didn't even read the rest of the stuff. I will definitely deduct marks from you here. You with me here? So, what do I do for the rest? Let's just read and see if they're talking nonsense here in long mathematical language. They say that the gradient is positive. Show me with your hand. For x less than -1. This way for x less than -1. Yes.
Yes.
For x less, it's positive. What do they say here? The
Gradient is bigger.
oh, I wrote down wrong. Sorry, you can't have it like this. I wrote it down. The gradient has got to be, I don't even have to check the textbook. I know I wrote it down wrong, otherwise it doesn't work. The gradient has to be, show me with your hand, negative. If x lies between -1 and 2, -1 and 2, negative. And then the gradient is, so that's negative. And then gradient is positive again. So what does it give me? Up, down, and up again. It's just confirmation that we already knew, but it couldn't work out any other way if I had those 2 turning points.
Yes, ma'am.
Are you happy on that?
Yes, ma'am.
But lots of explanation here because they wanted to maybe trick you in some way. But very importantly, turning point on the x-axis, and that is a specific point. You can't just say 2. It's not just a sketch graph and that objective. You still have other information as well. Where would the point of inclination be? The x value. There. Where would the point of inclination be? Point of inclination, what am I saying? Inflection. No wonder you don't know what I'm talking about. Point of inflection be at half, 0.5. Because it's exactly between the other one just now was a little bit more difficult to actually go calculate it. But between -1 and 2, halfway between is exactly at a half. Half and what?
Negative 3. Negative 3.
-3.
Yeah.
Because that's 0 and -6. Halfway be 3. So could they have asked you this after doing the sum?
Yes.
Easy, 2 marks. Normally when you hear the word inclination, no, inflection, what must you do?
Calculate.
Double derivative. Doesn't help here because I don't have the equation. But you must know that the point of inflection is where the concavity changes and that it's always exactly in the middle of those 2 turning points. Happy on that?
Yes, ma'am.